Today we are going to take a look at this HSI indicator. This is a modern unit. So this unit belongs to a friend of mine. On the front there are several push buttons and here two rotary switches, and there is also a push button in the center, and it is the same here for the course, reading and course, and there are other push buttons here. This thing was manufactured by Thales, a French company. This is a very nice design. Now we can see the push button here. Actually, this is the potentiometer. You can see the values here, 2.2 kilo ohms. I thought it was a rotary switch, but actually it is not the case. Now we can see 5 electronic boards. The power supply is here. So I will start with that board in order to find the power supply input. This is the power supply module. We have here a Max 697. We can see that some parts are not populated. We have two LT1846. This is obviously a pulse width modulation controller. We have several MOSFET transistors. The best thing is to do a quick reverse engineering of this board. It is not very complicated. There is a fuse here. The fuse is here. It is connected to this coil here. We have here probably the input filter with a fuse in series here. This is the datasheet of this pulse width modulation controller 1846. The first thing to locate is the power supply of this part, which is here, pin 15. We can locate pin 15 here. It is connected also to the second part. And I did this quick reverse engineering. We can see the power supply of the part. So first it is connected to this diode here, BAV70. The anode is connected to this Darlington BSP52, BSP52, this part here. And this part is connected to this MOSFET. So this is actually a protection against overvoltage. So we can see that we have effectively a pin 16, which is the power supply. There is a fuse and a coil here. And actually on the rear of this unit there is another board here with several diodes. And there is also this small board. We can see two coils and we can see this diode which is actually in series with the power supply. So this is the schematic of this small board. So therefore the power supply input is terminal A of the connector and the return is terminal B. So that makes sense. So I will reinstall everything and I will try to power on this unit, and after we will see the other boards. I am going to turn on the power supply for the first time. Okay, so we need the current higher than 1 amp. I will set the maximum current to 2 amps. Okay. Let's have a look at the other boards. There is here an FPGA from Altera. Here we have another programmable part. I don't want to remove the sticker because this unit is not mine. So here there is a voltage regulator. There is another part from Altera. And here we have several analog switches. We have two op-amps here. And here we have a switched baud regulator. There is here a Max 691. There is a small bodge here. But this bodge is very clean. We have here a CPU board. There is a CPU from Texas, SM34010. And here we have an EEPROM, 1 megabit. And there is here a CPLD from Altera, a clock frequency of 40 MHz. These parts are probably static memory. And there are some bodges here. Look at all these wires. The next one is a dual board assembly. We have also serious bodges here. Look at that. There is even here A7. I think it's a dual diode BAV99. So we have other bodges here. Look at that. We have these capacitors here. Oh, that's interesting. So we have a 285. I think this is a sample and hold, which is connected to this part. It's an ADC, obviously. So we can see other bodges here. Look at these MELF resistors. There is also a tantalum capacitor, other bodge here. I think that we have a synchro board here, maybe a synchro to digital converter. We have also an op-amp here, quad op-amp, and another one here. And we have two parts here from BI. So this is an array of resistors, 50k resistors. So it makes sense. They are associated with this op-amp here. These two parts are probably the same 50k resistors. And we have two others here. This is maybe a CPLD.
A few moments later.
It seems that we have effectively here a synchro front end. We can see the schematic here. We have two differential amplifiers. Each one is connected to one sample and hold here. And we can see that two inputs are connected together. So we have actually three inputs here. Next board is this one. We have several resistors here. Here we have two programmable parts. I don't know, this is maybe a microcontroller. And here we have probably an ASIC. We should have op-amps here. So here we have two quad comparators, LM2901. So I think that we have maybe the ARINC 429 interface on that area here. This is maybe the ARINC 429 controller. And here we have 5 identical circuits, A7. So we have also here dual diodes BAV99, I think. So this is maybe 4 configuration lines. It makes sense. We have maybe here a pull-up. This should be the ground. You have maybe clamping diodes, filtering here. So this seems to be an interface board. I think I will do the reverse engineering of this side here and also here.
A few moments later.
So this is effectively an ARINC 429. We have 4 ARINC 429 interfaces. This is a schematic of one input. There is a comparator here. You can see that we have actually two different comparators. We can see that the input here is permuted, so this permits to have at one output here the high level bit, and at the second output the low level bit. And the two outputs here are fed to this part, which seems to be effectively an ARINC 429 controller. The last circuit concerns these circuits here. We have here the schematic of one of them. So it seems that we have effectively a configuration input here. This line is connected to the connector. So this connector, we have a connection to the external connector. You can see that we have a pull-up here and a filter, clamping diodes as expected, and this is connected to an HC 244, which permits to read this input, and we have 5 identical circuits here. So it seems that we have 4 configuration lines, which permit probably to select between different inputs, ARINC 429, synchro, and maybe a self-test. It can be interesting to test these lines by connecting one or several of them to the ground. This power supply doesn't work. This is a complete schematic diagram of this power supply. There is first a step-up converter here. According to my calculation, we should have here a voltage of 46 volts approximately, but actually there is a voltage of 24 volts or something like that. Actually, this pulse width modulation controller doesn't work, and I have noticed that we don't have any voltage on that point here. The power supply comes from this simple circuit. There is a Darlington transistor here. I noticed that this diode is dead. It is an open circuit. This transistor is in short circuit, and there is also a short circuit on the power supply. Actually, we have 2 tantalum capacitors, one here and the second one is here, and one of them is in short circuit. Actually, this is the origin of the failure. This capacitor failed, and after that this transistor failed, and this diode also. This circuit is used at startup. A ground is missing here. Okay. When this controller is active, there is a voltage created by this secondary, and this permits to supply these 2 controllers, this one and the first one here. The second switched mode power supply generates the voltage of plus 5 volts here, which is totally isolated from the rest of the circuit. So I don't have the same capacitors, but I have this capacitor. It's 22 microfarads instead of 33, but the working voltage is higher, 25 volts instead of 16 volts. I will replace this Darlington by a MOSFET transistor and channel, of course. I expect to find a gate source voltage of 2 volts approximately, so this will do the job. And normally after that everything should work.
A few moments later.
So I have replaced this Darlington by a MOSFET. I have changed this diode, and I have replaced these 2 capacitors. Effectively, one was in short circuit, and this thing works. There is a test function. There is a software revision here, 0104, and the result of the test, good. That's all for this indicator. Thank you for watching, and see you next time for another video. Bye bye.